Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P0193, indicates a high voltage condition in the fuel rail pressure sensor circuit. This error is often related to the fuel rail pressure sensor's inability to accurately relay fuel pressure readings to the powertrain control module, PCM. The fuel rail pressure sensor is crucial as it monitors the pressure of the fuel entering the engine, playing a vital role in fuel management and vehicle performance. Located on the fuel rail, it typically consists of a connector with 3 pins and communicates voltage readings directly to the PCM. A high voltage situation can lead to improper fuel delivery, potentially causing engine performance issues. As such, the immediate troubleshooting steps should center around verifying the sensor and associated wiring integrity to ensure proper operation and to avoid further engine issues. DTC P0193 pertains to the fuel rail pressure sensor circuit, indicating a high voltage condition. The fuel rail pressure sensor is responsible for providing real-time data about the fuel pressure in the fuel rail to the PCM. Located on the fuel rail assembly, this sensor plays a pivotal role in maintaining the correct air-fuel ratio, affecting overall engine performance. Therefore, when it registers high voltage, it can lead to inaccurate fuel pressure readings, resulting in poor engine performance or even potential failure to start. The sensor is usually connected with a 3-pin connector, which can be checked for faults during diagnostics. A proper understanding of this system is essential in diagnosing the root cause of the high voltage error indicated by DTC P0193. Several possible causes can lead to the P0193 code appearing. First, poor electrical connections can bring inconsistent signals to the PCM, potentially leading to erroneous voltage readings. Secondly, a malfunction within the fuel rail pressure sensor itself may cause it to generate incorrect voltage outputs, hence triggering the DTC. Another significant factor may involve the wiring, where frayed or corroded wires can lead to voltage drops or surges that are interpreted as high voltage by the PCM. These aspects must be thoroughly examined. Moreover, if any loose terminals are noted at the fuel rail pressure sensor or the PCM, these should also be addressed as they may contribute to the sensor's improper functionality. The symptoms associated with DTC P0193 can significantly affect the vehicle's performance. One of the noticeable indications is fluctuating engine performance, where the vehicle may experience issues like stalling or rough running. Drivers may also encounter difficulties starting the engine, as incorrect fuel pressure readings can prevent proper fuel management. Additionally, the check engine light is likely to be illuminated on the dashboard, prompting the need for diagnostic attention. Given that these symptoms can escalate into more severe operational problems, early detection and troubleshooting are essential to maintain the vehicle's reliability and efficiency. Being proactive in addressing this DTC can help prevent potential damage to engine components that rely heavily on accurate fuel pressure readings. The first troubleshooting step for DTC P0193 involves verifying the initial problem through a series of measured checks. Begin by turning the ignition to the on position and allowing the vehicle to sit for 2 seconds. This initializes the sensor readings. Using the Honda Diagnostic System, HDS, examine the fuel pressure values converted from the fuel rail pressure sensor. It is crucial to determine if the current conditions align with the defined threshold, specifically confirming if values exceed 4.89 volts. If they do match the threshold, the failure is confirmed, allowing the technician to proceed to the next step. However, if not, consider it an intermittent issue that might require inspecting for poor connections or loose terminals at both the fuel rail pressure sensor and the PCM. Such preliminary troubleshooting helps identify whether the sensor is at fault or if a transient issue is present in the circuit. In Step 2, the technician will narrow down the potential failure area further. Start by turning the vehicle to the off-lock mode to ensure safety while handling electrical components. Next, disconnect the 3P connector from the fuel rail pressure sensor. Using a jumper wire, connect terminals A and B on the connector. A corresponds to the fuel rail pressure sensor connector number 1 and B to number 2. This simulates conditions to see if the sensor outputs the expected values when the car is turned back to the on position. Again, it is essential to check the voltage with the HDS. If the readings indicate more than 4.89 volts, then we can conclude that the sensor is functional and proceed to the next check. However, if the readings fail to meet this parameter, it is indicative that the fuel rail or the fuel rail pressure sensor itself requires replacement. In the third step, the technician will proceed to check the SG1 line or other potential faults. Commence by turning the vehicle off and then reconnecting the sensor. Next, remove any jumper wires previously connected to the fuel rail pressure sensor. Next, turn the vehicle to the on mode without reconnecting the sensor. Use a voltmeter to measure the voltage between test points 1 and 2, where test point 1 is the fuel rail pressure sensor connector number 2, and test point 2 is connector number 3. The target reading here should be approximately 5.0 volts. If the voltmeter confirms this value, then there is no issue with the SG1 wire. The technician can advance to the next step of troubleshooting. If the reading deviates from this threshold, it signals a fault in the wiring that needs further exploration. Step 4 centers on verifying the integrity of the PF wire line. Begin by switching the vehicle to off-lock mode for safety. With the HDS, jump the SCS line and allow it to sit for over a minute. After waiting, disconnect the PCM connector E, ADP. Then, validate continuity between test points 1 and 2, where test point 1 is the fuel rail pressure sensor connector number 1, and test point 2 is PCM connector E, ADP, number 72. Continuity here confirms that the PF wire functions properly. If continuity is observed, the PF wire is deemed intact. The technician should then check for any authorized service information related to the DTCs or symptoms, and may need to perform a PCM substitution to determine whether the original PCM is the source of the error. Alternatively, if continuity does not exist, an open circuit in the PF wire must be repaired to restore normal operation. In the final troubleshooting step, the technician must verify the SG1 line's functionality. Start off by ensuring the vehicle is set to off-lock mode for safety. Similar to previous checks, jump the SCS line with the HDS and wait for a minute prior to proceeding. After this, disconnect the PCM connector E, ADP. Continuity must again be checked, but this time between test point 1, which is the fuel rail pressure sensor connector number 2, and test point 2, which is PCM connector E, ADP, number 71. If a continuity check confirms that it exists, the SG1 wire is functioning correctly. The technician may then proceed to look through any authorized service information related to the DTC or symptoms. If a known good PCM is substituted into the circuit and DTC P0193 clears, then the original PCM will need to be replaced. Conversely, if continuity is absent, repair any open issues with the SG1 wire to ensure correct communication with the PCM. Upon completing the troubleshooting and necessary repairs, the final verification process is crucial to ensure that the issue is resolved. Begin by rechecking the fuel rail pressure sensor to confirm that it operates correctly and that it communicates appropriately with the PCM. Once confirmed, clear all DTCs from the system using the HDS. It is absolutely vital to perform a test drive under various conditions to ensure that the vehicle operates without any performance issues and that no new codes present themselves. By taking these steps, a technician can confirm the effectiveness of the repair, ensuring the vehicle is functioning optimally. This final verification is a key part of the repair process, as it guarantees all systems are operational and compliant with manufacturer specifications. To prevent future occurrences of DTC P0193 and ensure optimal vehicle performance, routine preventive maintenance is vital. First, regularly inspect the connectors associated with the fuel rail pressure sensor. Ensuring these connections are clean and secure can reduce the risk of intermittent faults and communication failures. Next, inspect the wiring for signs of wear, fraying, or corrosion. Any damaged wires should be addressed immediately, as they can compromise the integrity of the sensor readings. Additionally, maintaining the health of the fuel system, including regular fuel filter changes and keeping the fuel system clean, will promote smoother operation. With continuous attention to these aspects, a long-term, reliable vehicle operation can be assured. In summary, understanding the fuel rail pressure sensor's role is critical in diagnosing DTC P0193. Throughout the troubleshooting process, confirming the diagnostics at each step ensures a thorough approach in identifying the root cause of the high-voltage error. With potential issues ranging from poor connections to faulty wiring or sensor failure, a structured troubleshooting protocol is indispensable. Additionally, performing routine maintenance on connectors and wiring can extend the life of the sensor and improve vehicle performance. Investing time in these practices can help avoid costly repairs, ensuring the Honda Civic remains reliable and efficient on the road. Please like and subscribe to the channel. See you next time.